Okay, here we are at the bottom of page 4, so we're in section 2.3, page 4b for the video. Just a little helpful reminder of what we were just talking about at the top of the page. You'll find it on page 129. If you attempt to solve an equation and the variable becomes eliminated, you're doing all the right steps, but all of a sudden the variable, poof, goes away, then you're left with one of two statements. Either an inconsistent equation means no solution because what you end up with is a false statement like 2 equals 5. Or an identity, which means it's true for every real number because you ended up with a true statement such as 4 equals 4, or everything fell out and you kept subtracting or kept adding and you got 0 equals 0. That's true as well. Okay, so just a little reminder of what we just talked about. And then let's do a practice plus. Now, the reason why I want to do this practice plus together is because I want you to be able to kind of push yourselves a little bit, exercise your brain, get those thinking skills really going. We've started to get real comfortable again using variables, x's, y's, z's. You may have been a little rusty with that when we first started with Math 60, but now you're back into the swing of things. It's time to think. This is an example of thinking conceptually, not just black and white numbers on a page. So I wanted to walk through this because I think some of us, our brains like this kind of thing, and so it's like a puzzle. For some of us, our brains, this is not how we're wired. So I wanted to go through this for those of us that needed a little extra push on this one. So here's what number 66 is. It's an example of the practice plus here. Remember, we're in the section on solving equations, so we can expect that we're going to solve. And then here's the practice plus. We're going to actually not see any numbers in this. They're replacing every number with symbols. So the figures, box, triangle, the dollar sign, all represent numbers. Okay, so if we had seen x over 7 minus 4 equals negative 12, we would have known what to do with this. What you want to do is now practice those same steps even if you don't know any of the numbers. Okay, and there's a reason why the author's having us do this, not just to stretch our minds, but also it helps us to prepare for when the algebra gets more complicated. So let's go through this problem together with these same exact steps we've been doing this whole time. And if you need to, pull out those steps and use those right next to you. The goal, step 1, simplify, step 2, pick a side, step 3, what's happening to x, step 4, undo it, step 5, check. Okay, so let's isolate x. That's our goal as well here. So we want to get x all by itself. Okay, there's no parentheses. There's no like terms, a dollar sign, triangle, square, they're all different from each other. So we really get to move right to that, what's happening to x? Okay, so if a number was put in the x position right here that I've kind of highlighted in red with the red pen, what would happen? Well, according to order of operations, this fraction, this division would come first. It would get divided by the box, then the triangle would be subtracted. So we'll go ahead and just write that. Just like we've always written that list. The first thing that would happen is it would get divided by the box. We're just used to seeing a number there, not the box. The second thing that would happen is that you would subtract the triangle. Okay, it feels kind of funky, right? Let's do that as a timeline. X divided by the box and then subtract the triangle. Again, we're going to read that timeline left to right. Either one of these methods will work for you, or you might have a third, your own method that works just fine. So now let's undo that. Let's get ready to solve this. We're going to undo that by going up the list, or timeline, we're going to go right to left. We do the opposite of what we discover here. We're going to go first step, second step, up the list here. Subtract is going to be add. Divide is going to be multiply. Same thing here. As we go right to left, we're going to, instead of subtracting the triangle, we're going to add the triangle to both sides. Then we're going to multiply both sides by the square. So now we do that. We do exactly what our list says. We're going to start by adding the triangle to both sides. Normally when we add to both sides, we are able to combine those two numbers into a single number. This time we won't be able to because we don't know what those numbers are, but we can still write it out. We're left with the x divided by the box, or the square, equals, because the triangles cancel each other out, so it equals negative dollar sign plus the triangle. So it's negative dollar sign plus the triangle. Or if you wanted to think of it as, if you wanted to put the subtraction second, you could think of it as x over the square equals triangle minus the dollar sign. Those are the same thing, okay? Again, we just don't know the numbers, and we're just going through the exercises because the steps should work no matter what. So we've taken care of adding a triangle to both sides. Now we're going to multiply both sides by the square. According to the timeline, that's what we do too. We reverse the order, go right to left. We took care of adding the triangle. Now we're going to multiply both sides by the square. So when we do that, multiply both sides by the square, notice I'm going to multiply this entire side by the square here. The squares are going to cancel on the left side. That was the whole point, leaving you with just 1 times x over 1 times 1, or just x. And over here you've got square times outside the parentheses, triangle minus the dollar sign, or if you kept it as minus the dollar sign plus the triangle, that's fine too. Those are the exact same. And we get to distribute. We're multiplying the entire side here by that square. So it becomes square times the triangle minus square times the dollar sign. Or if you'd kept it in the original order without switching it around, it would be a negative square dollar sign plus square triangle. Or you might have even kept the dollar sign in front, minus dollar sign square plus triangle square, either one. Okay, it's a little bit of a tongue twister. It's a little bit funky to kind of write it all out here, but here's our x. It doesn't feel very solved. It feels very foreign, and that's why I wanted to do it together. Because the point is, the steps work no matter what kind of junk you're looking at, whether it's numbers or a whole bunch of variables or symbols that maybe you're not familiar with, or a big complicated looking equation. It doesn't matter what it looks like. These steps will still work. It may not collapse and combine all pretty into one single little answer like we're used to, but you've still done the job of isolating x. You've still solved this equation. Okay, now what the meaning of that solution is, well, we don't know anymore right now, but we've done our job, and that's to solve it. Okay, so it walks you through that on the Practice Plus. Let's try some more on page 5. We'll see you there.